Now that we have just practiced how to solve one linear inequality, we're going to look at a system of linear inequalities. So please make sure you've watched the last video before this one, which is graphing a linear inequality, and make sure you've watched this video before you try to do any linear programming examples, which are coming up next. So let's take a look at this first example together. We're going to graph both of these. I'm going to graph the first one in purple, the second guy in green. And they're both inequalities. I'm going to graph just their lines first, and then we'll talk about a strategy for finding where we should shade. So if I were to graph the first one, it's in standard form. Standard form, I typically use the cover-up trick if I'm able. So I get y is -3, and, whoops, then I get 3x is 3, so 3x is -3, so x must be -1. This one's a straight, solid line, so connect them with a nice solid line. Then I'm going to look at the green equation, and using the cover-up trick again, I get 2y is 4, so y must be 2. And I get x is 4. And this guy is a dotted line. So far, so good. Now, if this were just a system of equations, the thing I would be most interested in is this guy right here, where they cross, which is at -2, 3. So that's what we did before when we solved systems, but this time I'm less interested in the exact point where they cross, and I'm more interested in the region that they cross. So the region, let me just separate this out, 1, 2, 3, 4, and we're going to look at trying to get rid of one of those. So one of those 4 regions is going to be shaded in. So how do I figure it out? Well, essentially what I'm going to do is I'm going to look at the purple equation first, equation 1, and I'm going to determine left or right of equation 1, because that's going to help me to get rid of 2 of those zones. So if it's to the left, 1 and 4 are the only options, and 2 and 3 can go away, vice versa. You get the idea. So choose a point on one side or the other of the purple equation. And guess which one I'm going to choose? This should not come as a surprise. Let's choose 0, 0. If I choose 0, 0, I get 3 times 0 plus 0 is greater than or equal to -3. That 0 is greater than or equal to -3. Is this in fact true? It is true. 0 is bigger than -3, which means that the purple equation should be shaded to the right. So it could be 2, it could be 3, it cannot be 1 or 4. So I've cut it in half. Now I just have to do it again. I'm going to use the green equation, and it's going to be above or below. Choose a test point that's not on the green line. Guess which one I'm going to choose? 0, 0. 0 plus 2 times 0 is less than 4. 0 is less than 4. 0 is less than 4. It is true. 0 does happen to be less than 4. Because it's true, the 0, 0 should be shaded, which means below the line, whereas before we said to the right. So below the line is shaded, which means it can no longer be 2, it's got to be zone 3. So how am I going to shade it? I'm going to shade everything in this region. So this guy is a little bit different because it's not 2 straight lines. The first one, because it has an x squared, is a quadratic, so it's going to be a parabola. And my parabola is actually going to be facing down. And again, I know that because if I rewrote it in the form that we're used to, it would be -x squared plus 4. Also, knowing what I know about a quadratic written in this form is that a is -1, b is 0, c is 4. My intercept is going to be at 4 on the y-axis. my vertex is going to be at negative b over 2a, which happens to be 0, but I don't have to find another point because I already know that at 0 we're at 4. Then I might just, find another point. So let's plug in x is negative 2. That would give me y is less than 4 minus negative 2 squared. Well, that gives me 4 minus 4, which is 0. So when I plugged in negative 2, I got 0. Let's reflect that. That's as precise as I'm going to be. This is a solid line because it's nor equal to. So essentially that's what my graph looks like, give or take. My other one, obviously much easier because it's just a line. I'm going to start at 0. I'm going to use up 2 over 1 or down 2 to the left 1. You get the idea. This guy is also going to be solid. So now I've got several regions that might be shaded. It might be everything out here, which would be all of this. Okay, it might be everything out here, which would be all of this. I'm going to get rid of the squiggles because it makes it harder to understand. Could be this little region right here, or it could be below the green line the rest of the way down. Again, how do I figure this out? Well, let's use the purple equation to see if it's outside or inside. Ooh, goodness, let me try that again. Outside or inside. Now, how do I determine that? Yep, choose a test point that's either outside or inside. Guess which one I'm going to choose? 0, 0. So I can choose it for the purple because it's not on the purple line. 0 is less than or equal to 4 minus 0 squared. 0 is less than or equal to 4 minus 0. 0 is less than or equal to 4. True or false? 0 is less than 4. True, which means 0, 0 needs to be shaded, so that means it's inside, which means it's no longer region 1 or 2. It has to be 3 or 4. How do I choose if it's 3 or 4? Well, I'm going to have to use a test point, and unfortunately I don't get to use 0, 0 because, as you can see, 0, 0 is on my line. So choose a point that is either to the left and above the line or to the right and below the line. Let's choose my favorite point, 7, 0. Any point that you want is fine. And notice it doesn't matter that I've chosen a point that's not inside the parabola. It doesn't matter. I'm just trying to do right or left. So right or left of the green line, I'm choosing the point 7, 0. So 0 is less than or equal to 2 times 7. I'm sorry, greater than or equal to. 0 is greater than or equal to 14. That is false. 0 is not greater than 14, and therefore I cannot shade to the right. It has to be to the left. Which region is to the left of my green line? Region 3. So region 4 is out. Region 3 is in. That means this is my shaded region. Here's our last example, and I would like you to try it on your own. If that first equation is a little intimidating for you, wait until we're done graphing the lines to do the shading and do the shading on your own, but you really should try to practice on your own. So I do have 3 this time, which is a little bit harder than last time, but we're gearing up for linear programming, which are going to have 3, 4, 5, maybe 6 equations. So to graph this, the first guy is a circle. I know that because I'm used to that equation. The center of my circle is 0, 0. My radius of the circle is the square root of 25, or 5. So I'm just going to go 5 in each direction of 0, 0. And I'm drawing a solid line. I'm going to do the best I can to make it look like a circle. But, I'm not an artist. You get the idea. Number 2 is just a line. Again, you can turn it into slope-intercept form. Y is less than or equal to x plus 1. Start at positive 1, use a slope of 1. This guy is dotted. I could have also done that just with the cover-up trick and just had those 2 points. It's the same thing. Last equation, y is greater than or equal to -4. So I go to where y is -4, and I'm going to draw a solid line. Whoops, try to draw it actually on the line. And so that made it worse, right? Because I've got a lot of regions, but I'm still just going to go about it in a very, precise way. So I'm going to start with equation 1, and I'm going to look for inside the circle or outside. Why can I not write the word outside today? I don't know. Again, you can number your regions. So I have this region here. I've got this region here. I've got this region here. This region here. All 4 of those are outside the circle. Then I've got this region inside, this region inside, and then this little guy inside. So 7 regions to check, but again, it's going to be close to the same amount of work. I'll have to check one more than normal. So inside or outside, choose a point inside the circle or outside the circle. Guess what? 0, 0, inside the circle, so I'm going to choose it whenever I can. 0 squared plus 0 squared is less than or equal to 25. 0 is less than or equal to 25. True or false? 0 is less than 25. Therefore, 0, 0 should be shaded, and 0, 0 was inside the circle. So that told me not 1, not 2, not 3, not 4. Now let's look at 2. I've got 0, 0 would be a great point. I'm looking for above / to the left or below / to the right, however you want to think about it. I'm going to use negative, oh actually, you can use the original equation. I'm going to use this guy. 0 is less than 0 plus 1. 0 is less than 1. True. 0 is less than 1. 0, 0 should be shaded. That's the below and to the right situation, which means it can't be 5. So now I'm just choosing between 6 and 7. How do I choose between 6 and 7? I have to choose above or below. Guess which point I'm going to choose? 0, 0. 0 is greater than or equal to -4. Well, that's true. So 0 is greater than -4, and 0, 0 is above the line. So that means can't be zone 7. It's got to be zone 6. So zone 6 is right in here. That's my solution.